For this worksheet, factors affecting resistance, some of the easier questions actually you don't need to show the full working, but for completeness sake and as a matter of good practice, I will do the complete working for all questions. Okay, so for the first question, you're given wire A resistance 2.4 ohms, wire B half the length, right? So what's the resistance? So wire A, we say that it's rho L over A, and it's 2.4 ohms. Therefore, wire B has half the length, right? So half L over A, which you take the half out, you get half rho L over A. So it's half times, this is actually 2.4, right? So half of 2.4 is, oops, my pen is not working. 1.2 ohms. Okay, number 2. Okay, for questions which you find that it's really straightforward, you can straight away write RB equal to half times 2.4 equal to 1.2 ohms. Okay, actually you can do that. It will be okay. All right, for number 2, cross-sectional area 0.4, resistance 10 ohms. Another wire, same material. By the way, if you see same material, right, they're telling you that the resistivity is the same, right? The resistivity is the same. Okay, so you don't need to consider the resistivity. Okay, another wire of the same material, same length, okay, has cross-sectional area of 1.6, which means that it is 4 times of 0.4. Okay, so if the cross-sectional area is 4 times, what happens to the resistance, right? So resistance of A, let's call it A lah, okay, will be rho L over A, or we call it resistance 1, because there's already an A for area. So then 0.4, 10 ohms, 10 ohms. So R2 will be, you have 4 times of the area, so rho L over 4A. So you take out 1 over 4, take out 1/4, right? So you get 1/4 of 10, which gives you 2.5 ohms. Okay. Question 3, we have length 0.25 meters, cross-sectional area 0.5, resistance 2.0 ohms. Another wire, same material, length 1 meter. That means that the length is 4 times. Okay, from 0.25 to 1 is 4 times. And cross-sectional area of 0.25 mm square. So from 0.5 to 0.25 is half, right? So half times. The area is halved. So what's the resistance of the longer wire? So let's call it R1. R1 is rho L over A, which is 2 ohms. R2 will be rho times the length is 4 times 4L, and the area is halved, so half A, right? So 4 divided by half is 4 times 2. Okay, so 4 times 2 is 8 rho L over A, right? So you get 8 times of 2, which is 16 ohms. Okay, question 4. Right, question 4 is slightly more difficult. All right, because there's involvement of radius. Okay, we are assuming that the cross-section of a wire, we are assuming that it's a circle, right? So if you assume that it's a circle, then the area is equal to pi r square, right? So first of all, we need to determine the relationship between the old and the new wire before wire 1 and wire 2, the relationship between them in terms of their areas. Okay, so we see that the radius has increased from 0.25 to 0.5. That means it's twice, right? So we know that area, let's call area 1 is pi r square, okay, which is 0.25 actually. Now don't need to calculate it out because we only need to know the relationship. So area 2 is pi of 2 times of the radius, right? 2 times of the radius, okay, squared, which means it's equal to 4 pi r squared. So that means it's 4 times of area 1. So in other words, when the radius is doubled, the area is 4 times. All right? If the radius is 3 times, then the area will be 9 times. That means you need to square it, right? So 2 squared is 4. So that means that the new area is 4 times of the area of the old area. Okay, so now that we know the relationship between the areas, we can carry on doing like we have done for the past few questions. Okay, so we are told that length of first wire is 1 meter, length of second wire is 4 meters, material is the same, so rho is the same. So R equal to R1, let's call it rho L over A is 0.1 ohms. Okay, R2 is the length, as we have said, is 4 times. Okay, the area is also 4 times, right? Okay, so 4 times over here and 4 times over there. Actually, it will cancel out and you are left with the same thing, right? So rho L over A is actually 0.1 ohms. So in the end, the new wire actually has the same resistance as the old wire. Okay. So this table is to help us to practice, all right? So just to recap, R is proportional to L. Whatever happens to the length, it will happen to the resistance. So if the length is half, resistance will be half. Length is doubled, resistance will be doubled. And resistance is inversely proportional to area. So if the area is doubled, then the resistance is halved. If the area is halved, then the resistance is doubled. So it's just divided by that factor, right? If the area is 4 times, then the resistance divided by 4. Okay? So your original conductor is 12 ohms, right? So now we look at the first one. Length is 6 meters, which is 3 times, right? And area is the same, so no change. So your resistance will be 3 times of the original, so it's 36 ohms. The unit is up there in the heading, so I'm not going to repeat it. All right. Now for practical exams, your table need not show working, right? But this is for our practice, so I want to show you how the calculation was done, so I'm showing the working here. Okay, number 2, length is 1 meter, which means that it is halved, right? So length is halved. Cross-sectional area, no change, right? So no change. So no change means that only half of the original resistance is 6 ohms. Okay, so length is half, therefore resistance is half. Area no change. Okay, next, length is the same, all right? So no change compared with the original length. So now the area is 3 times, right? Okay, 3 times. So 3 times the area. So 3 times the area. We have area is 3 times, therefore the resistance will be 1/3 divided by 3 lah. So 12 divided by 3 is 4 ohms. Okay. Next, your length, no change. Your area is halved, right? Area is halved. So half, 1 over half is 2. Okay, 1 over half is 2. So 12 times 2, okay, is equal to 24 ohms. Next, we have length is halved. Okay, from 2 meter to 1 meter is half. Then from 0.8 to 1.6 is 2 times. All right. So area is halved. Then the cross-sectional area is 2 times. So 2 times 1 over 2 is half also, right? So 1 over 2, then times 12 ohms. You get 12 divided by 4 is 3 ohms. All right, next, length is 0.5. Okay, so from 2 meters to 0.5 is divided by 4, right? So it's 1/4. Then from 0.8 to 0.4 is half, right? So length, you times 1/4. Then the area, 1 over half is 2, right? 1 over half is 2. So half, 1/4 times 2 times 12, right? You get 6. Am I right? Am I right? Divided by 2, yeah. Okay.